Okay, video 6B. Let's do an ordinary annuity. To save for their grandchildren's college expenses, Ken and Kendra invest $500 each month so I know N is 12, P is 500. In ordinary annuity, 6%. Determine the amount in their annuity after 18 years. So they're putting away $500 a month for their grandkids' college. What's the total amount they're going to save? Remember P star, that's the principal total, lump sum. So it'd be 12 times 18 times 500. 500 a month for 18 years. They're actually going to, probably could do this very quickly. That's 6,000 times 18. That's 108,000. Let's make sure that I got that right. 500 times 12 times 18. Yep, 108,000. So that's their total outlay out of pocket that they're actually putting into savings. What's that going to be worth after 18 years? So here it is. We use this formula. So NT, 12 times 18. Let's do that on the side. 216. For 216 months. And when they do this, they end up with $193,676.60. It's 5972 rounded up to 60 cents. You can check my arithmetic. So they almost doubled, not quite, almost doubled their money. Doesn't say how many grandchildren they have, but that should pay college tuition for at least a couple. Who knows? All right, here's another one where Nick wants to save up enough cash in the next 6 years of working in order to have $24,000 to purchase a brand new motorcycle. Six years. He wants to do it monthly in a sinking fund that pays 7.5%. So this is a sinking fund, so we use that formula. So let's see, this was problem 5. This is problem 6. Okay, so how much per month? So we use P equals A times R divided by N, 1 plus R divided by N, caret NT, 72 months. So Nick would have to spend or save every month $264. Now here's one where it's 9626951. What we do is we round this to 7. Regardless of the fact that that's a 2, we still round it to 7. Otherwise, Nick would end up with $23,997 or something like that. You'd be a couple bucks short. So this is the delayed gratification, because we could use the long-term loan and see what Nick has to pay if he were going to buy the $24,000 motorcycle today and have six-year payments, right? We could use the installment loan. You remember that? We could say M equals, just to show you the difference. Got to look up the formula because I forgot it off the top of my head. M equals P times R slash N divided by 1 minus 1 plus R slash N caret to the minus NT. So, let's see what this is. 24,000 times R. We'll assume the same percentage rate to make things fair, or equal, whatever. So NT, once again, is 72, so that's negative 72. I don't need the extra parentheses there because I solved for minus NT. And if we work this out, let's see what we get. So left parentheses, 24,000 times 0.075 divided by 12, right parentheses, divided by left parentheses, 1 minus left parentheses, 1 plus 0.075 divided by 12, right parentheses, caret, negative 72, right parentheses, $414 and 96 cents. So that's his monthly payment to buy the $24,000 motorcycle. What's his total interest? Well, that would be 24. Wrong number. That total interest would be 414. What? Gosh darn it. 414.96 times 72 minus 24,000. So let's see what that is. So 414.96 times 72 minus 24,000. $5,877.12. So he would be paying almost 30,000, 29,900, just about. He would be paying almost 30,000 if he bought it today and paid it off in 6 years at the same rate. Whereas if he saved this much every month, let's see what that is. The principal here, it's $264.97 times 72. His total outlay here would be $264.97 times 72. 19,000. It's almost a wash. He either pays almost $6,000 interest if he buys it today, or he gains almost $5,000 interest if he waits for 6 years. What's the difference? The difference is he has the motorcycle for 6 years. So it all depends on what his plans are. If he wants the motorcycle now, he can buy it now. If he wants to save for later, then he saves money in the long run because he's spending less per month for 6 years. See, $264 versus $414, $150 difference. So it all depends on his lifestyle, what he's doing, what's going on. All right, one more problem. this one is a comparison for two young ladies who have a long-term goal for retirement savings. They each go about it slightly different. So we'll use their names with A and Z. So one of them is Annie. The other one is Zena. So Annie invests right after college for 10 years from age 25 to 35 by putting $100 per month into an ordinary annuity that paid 5.5% interest rate compounded monthly. So Annie. Per month for 10 years. And we're going to keep the rates the same. So all things being equal, if you have the same rate, you can make a pretty good comparison. So this is an ordinary annuity. So how much did she have after 10 years? So her future value will be 100. One plus 0.055 divided by 12. Caret NT is 120 minus 1 divided by 0.055 divided by 12. I think I might have. No, that's good. So her future value on the annuity is $15,950.76. So after 10 years, that's how much he has. Okay? But then at age 35, Annie stops making payments and invests the accumulated value from the annuity into a savings account with an interest rate of 5.5% compounded monthly. After 30 years, when Annie is 65, how much is accumulated in her savings account? So for 30 years, at 5.5% compounded monthly, she puts it into a savings account. It's compounded monthly. Okay, so A is equal to, if you remember the formula, it's P times 1 plus R over M to the NT. So that'll be $15,950.76 times 1 plus 0.055 divided by 12. And for 30 years, that'll be caret 360. Monthly for 30 years. So she no longer puts any money in. She's done putting money in. She got a lump sum and she invested in this account. And so she will have $82,742.78. So that's her total future value. Okay? So what's your out-of-pocket expenses? What's your total principal? Well, it's 120 months times $100. So $12,000. So she invested $12,000 and 40 years later she has $82,000. She puts it away. Zena, on the other hand, went to work out of high school at age 20 and invested $50 every month in an ordinary annuity with an interest rate of 5.5% for 45 years. She went from age 20 to age 65. She just kept putting $50 a month. That's all she did, $50 a month. So her future value so 45 times 12, so we'll just go ahead and use parentheses. That's 0.055 divided by 12 at the end there. So her future value for her annuity is $117 or $117,000. Anyway, that's what it is. It's a little more than Annie, obviously. Of course, the thing of it is, what was her out-of-pocket expenses? So her total out-of-pocket expenses were the $50 a month times 12 months times 45 years. And if you work that out, it's $27,000. So she more than doubled Annie's input, but she got much more back. So the question is, which investor made more future value? Well, obviously, Zena did. She made more future value. But who made the better investment? How can we figure that out? Well, there's a couple ways to do it. You could say, what's the difference between these two? It's if you subtract 27, the difference is, let's see, if I subtract 27, I get $90,978.66. Here, if I subtract 12,000, the difference is $70,742.78. So that's the profit. The difference is the profit from the investment. So still, it looks like Zena made the better deal. But then another way to consider is, what if you just did a ratio for how much they made per dollar invested? So if I divide this by a 12,000, so for Annie, if I divide 82,742.78 by 12,000, and for Zena, I would divide 117,978.66 by 27,000. That gives you the amount earned per dollar invested, and it's going to be better for Annie. Let's see how much. So, oops, gotta do it again. So this is, she made almost $7. We'll call it 6.90. She made $6.90 for every dollar she invested. Whereas Zena made $4.37. So it's an academic thing. If you want to go by the amount of increase, then academically you'd say Annie did better. But if you're looking at the money in your pocket, Zena did better. She's got more money by 35,000 more. So you can brag all you want about how much you made on the investment percentage-wise, but when push comes to shove, how much do you have in your wallet, right? Okay, so that's it for the videos for this course. That's video 6B. Make sure you contact me if you got any questions. Dr. K out.